Hello guys, and welcome to our next video about concurrent programming. Our idea is simple enough. We are going to do some concurrent programming in Golang and then implement the same thing in Python as in the previous videos. Today's topic is rather important, and it's about communicating between concurrent components. So as you expect, the most part of the concurrent programming is sharing something between threads or concurrent components. With Golang, it has its unique approach, and for me it's most elegant one actually. And let's see what they have written about this. So the topic is from blog Goblog, and the name is Share Memory by Communicating. And let's just read through to get the base grasp of the idea. So the traditional threading models commonly used when writing Java, C++, and Python programs, for example, requires a programmer to communicate between threads using the shared memory. And whenever you share something, you need to protect it. That's why typically shared data structures are protected by locks. You can hear something like lock, mutexes, semaphores, and something like this is a synchronization primitives that just protecting the shared component from some kind of I don't know, overusing or abusing, if it's okay to say, yeah, content over those logs to access the data. But Go's concurrence primitives such as coroutines and channels, so the channels is a new thing for us, to provide an elegant and distinct means of structuring concurrent software. So the Golang's approach is using the CSPS, the communicating sequential processes algorithm. And instead of explicitly using logs to mediate access to the shared data, Go encourages the use of channels to pass references to data between coroutines. So what does it mean? It's just kind of, there's a channel that imagine is like pipe. You have some coroutine that putting some data or just sending a reference to some memory object, and from another coroutine you can read this, so that's another end of this pipe. You can read this sent data, and this approach ensures that only one coroutine has access to the data at a given time. So there's no need for logs, because you can only once put something in the channel and you can read at the other side it will read through the channel. And the concept is summarized in the document of effective Go. So do not communicate by sharing memory. Instead, share memory by communicating. So in the next video, we are going to implement we are going to write some simple Golang code with using the channels, and then we are going to implement the channels in Python using the asyncio built-in methods. So there's no such built-in thing in Python for supporting this CSP. The only thing we can do here, like write some wrapper or simulate this channels effect using Python's asyncio. That's it. So it's the intro to the Golang's another concurrency primitive to channels. We have seen these coroutines and also the weight groups in the previous videos, but now we are going to explore the channels and implement the same idea in Python. So that's it for now, and see you in the next video. Bye.